Today's video is about systems of nonlinear equations. That is, systems that have a few equations and a few variables, and at least one of the equations is nonlinear. What do we do to solve them? One way is to eliminate all variables except for one, and then solve for that one variable, and then plug that into the other equations and eliminate again and solve again. Or sometimes if there are two equations and two variables, when you solve for one variable, you plug it into one of the equations and then solve for the other variable. Other ways of doing this is to actually solve for one variable with respect to other variables, plug it into the other equations, and so on and so forth. I would like to give you 3 examples with where one of the equations is linear, and then move on from there. So example 1. And this is so in here I see that one of the variables is already solved for the other ones in both equations. One of the variables is solved in terms of other one in both equations. So one way to do this, rather than eliminate, I can think of this. I can replace this variable into the other equation and then solve. So here again, it's the same thing as elimination. So in the first equation, I'm replacing x minus 2 for y, or eliminating, either way. Now I got to this equation. I have x to the power 2 and have x, and I have a constant on both sides. This is a clue that it's a quadratic equation, so I have to subtract both of these and get x squared minus x. Minus becomes plus 2, and added to 4 is minus, and added to negative 2 is minus 2. Solving this quadratic equation, I can see that I can factor this one. It's x minus 2 times x plus 1 equal to 0. This gives me 2 solutions. One is x equal to 2. The other one is x equal to negative 1. The next step in solving, so I solve for x, but it's a system, I have to solve for y as well. I have to plug x equal to negative 1 and x equal to 2 back into the equation to solve for y. Which one should I choose? I usually do the one that is easier for me. So I go plug it back into this equation, which is the linear one. And so here, for x equal to 2, I plug it back into the linear equation, and y is equal to 2 minus 2 equal to 0. For x equal to negative 1, I plug it back in. Negative 1 minus 2, so y equal to negative 3. And y equal to 0. So the solutions, I have 2 points that are solution for this system. One is the solutions are, that was x equal to 2, gave me y equal to 0, 2 and 0. The other one was x equal to negative 1, gave me y equal to negative 3. So I got 2 solutions out of this system. The next 2 examples that are similar to this one, they have a they have a nonlinear and a linear equation as in the system, will demonstrate that you can get one solution out of similar systems or no solutions at all for similar systems. So remember this one, and we erase the board and we come back. So we're continuing with systems of nonlinear equations with the examples that one of the equations is actually linear. So the first example, the second example is y equal to x squared plus 4 and y equal to x minus 2. Again, I can eliminate y between the two of them, or the other way of saying that, I can replace y in here by x minus 2. So x minus 2 equal to x squared plus 4. And what do I get? I get x squared, subtracting x from the other side, minus x, subtracting negative 2, which is adding 2 equal to 6 equal to plus 6 equal to 0. Solving this system, let's try to use solving this equation, is I can use the quadratic formula for it. Minus b is 1 plus minus square root of negative 1 to power negative 1 to power 2 is 1 minus 4 times 6 divided by 2. Under the square root is a negative value, therefore the solution does not exist. And another way of describing this is the equation on top is that parabola x squared plus 4. And so parabola x squared plus 4 is 4, opens up that way. Then the equation on the bottom is the line y equal to x minus 2, and that would be minus 2, this line. And they do not meet, therefore there is no solution. So the third example in this series is going to be y equal to x squared plus 2, y equal to 4x minus 2. Again, the same method applies. We eliminate y between the two of them, and we get x squared plus 2 equal to 4x minus 2. Subtracting gives me x squared minus 4x plus 4 equal to 0, according to quadratic formula, or remembering the factoring gives you x minus 2 to power 2. Using quadratic formula gives you the same thing that this one gives you, x is equal to 2 repeated. And then to find y, you have to plug it back to the above equation, and you get y is equal to 4 times 2 minus 2, and I'm choosing the one that is less complicated operation-wise, and we get 6. So 2 and 6 is the only solution. Let's look at the picture. Y equal to x squared plus 2 is a parabola that goes like that. Y equal to 4x minus 2 is a line that goes like this. And so at x equal to 0, it goes through this point, negative 2. And then it goes through 2 and 6. Like that. And it would be so at 2 and 6, the line is tangent to the parabola. If you want to go back to example 1, now you can actually observe that example 1 was this equation. In that case, the first one was a parabola, and that would start at the vertex would be 0 and -4, and then it would open up going up there like that, and then x minus 2 is the line that goes through right here. And so there's two solutions were this point and this point in example 1. Again, looking at the three examples, one of them we had two solutions, 2 points. So the two equations or graph of the two equations intersect into 2 points. One of them intersect in 1 point, and the other equation did not intersect. And so those are the options that we're getting with these equations.